This is the second set of slides on stoichiometry. It's actually the third video, but the second set of slides, this is where we get problems a little bit more complicated. I'm not sure if this is going to take one video or two, so you'll know by what's posted. All right, so again, you want to have the slides with you while you're doing it so you can go back and forth and hit any liberal use of the pause button, and reviewing your material on writing equations is going to be critical to this. The dimensional analysis isn't quite as complicated, but you've done a lot of that. All right, so let's just jump right into this. Let's look at this problem. This problem says, what mass of silver phosphate will be formed from the reaction of 4 grams of silver nitrate with 2 grams of sodium phosphate? So let's have you write the balanced equation and then diagram it out. So hit pause and write the equation. All right, hopefully you're back from pause. So there's the balanced chemical equation. And then to diagram it out, all right, hopefully your balanced equation came out the same as mine. Okay, to diagram it out, we are told we have 4 grams of the silver nitrate, 2 grams of the sodium phosphate, and we're asked how many grams of silver phosphate. Right, so you might want to ask, what's different about this problem? And the answer is, in all the other problems we did, you were asked about one thing and told about something else, right? You were asked about nitrogen, ammonia, and told about hydrogen or something. You were asked about sodium hydroxide. You were told about sulfuric acid. You were asked about, each time you were asked about carbon dioxide and told about octane. But here, you're asked about sodium silver phosphate, but you're told about 2. So the question is, well, how do I start from the silver nitrate or do I start from the sodium phosphate? And the answer is we have to figure that out. Okay? This is what's referred to as a limiting reactant problem. So if we were to mix silver nitrate with sodium phosphate, backing up a slide, they will react and they'll form silver phosphate and sodium nitrate. And they'll keep reacting until we run out of something. All right? As soon as we run out of something, the other thing has nothing left to react with. So for example, if we run out of silver nitrate, the sodium phosphate can't react, or vice versa, right? The reactant that we run out of will determine the amount of product. That's the one that's used up. This is referred to as the limiting reactant. Okay, the next slide is another example. So we're going to go back and we're going to solve this problem. So just hang in there, but I'm going to do something in between that's a little easier to see, right? My colleague did this one. So let's say we make ham sandwiches using the balanced equation. 2 pieces of bread plus 1 piece of ham makes 1 sandwich, all right? And so if we had 2 pieces of bread and 1 piece of ham, we could make 1 sandwich, right? Now, do you agree this is similar to a balanced chemical equation? There's not a picture here. I don't know what happened. I must have got screwed up. All right, there's the sandwich, all right? But what if I had 8 pieces of bread and 8 pieces of ham? How many sandwiches could I make? So try this in your head. I think you guys can probably figure this out. The fact that you can do this in your head means that you can actually understand the concept of a limiting reactant. Right? I'm going to give you a step-by-step approach to this. The answer is 8 pieces of bread and 8 pieces of ham. Right? So if we kept going, you'd find out that you can make 4 sandwiches and you'd have some ham left over. Okay? So that means that your bread was the limiting reactant. So it's the same thing with the silver nitrate and sodium phosphate. So just some definitions. Limiting reactant is what's used up. The excess reactant is what's left over. Right? So these are my steps to solving limiting reactant problems. Now I want you to understand the textbook does this a little bit differently. The lab manual does it differently. I'm going to show you 2 different ways, and I have colleagues who teach this differently. There's probably 5 or 6 different ways to do this. Nothing is wrong with any of the methods. Obviously, I like my method better, or I wouldn't show it to you. But if you see another way to do this that you like better, then do it that way. All right? So the steps are very simple. First, we write a balanced equation, and we realize it's a limiting reactant. Then what we want to do is we want to determine the number of moles of each reactant that we have. Then we arbitrarily pick 1 reactant. It doesn't matter which. There's 2 reactants. Pick 1. Find out how much of the other that you need to use it up. and then you determine the limiting reactant. And this is where it's really important that you label things. You compare the moles of what you have to the moles of the same reactant that you need. And then if what you have is less than what you need, it's limiting. If what you have is greater than you need, it's not limiting, which means the other reactant is limiting. And yet you still haven't answered the question. So then what you do is you use the moles of the limiting reactant that you have to answer the question. All right, so let's do this with the ham sandwiches. Okay? So the ham sandwiches example. There's your balance equation. So then what we're going to do, steps 2 and 3, write down the moles of each thing we have. So if we have 8 pieces of bread and 8 piece of ham, then we're going to arbitrarily pick the bread, see how much ham we need to use it up. So for 8 breads, we need 1 ham for every 2 breads. That's from the balanced chemical equation, 1 ham for 2 bread, meaning we would need 4 ham if we're going to use up all the bread. Step 4 is we're going to compare what we have to what we need, but we have to compare the ham to the ham. All right? And so you can see in this case, this is the comparison, that's the arrow, that I have 8 hams, but I only need 4. That means what I have is greater than what I need. That means this is not the limiting reactant. Since there's only 2 reactants and this one's not limiting, that means bread is the limiting reactant. Right? So then the last step is we take the moles of the limiting reactant to answer the question. Right? Okay, I'm going to stop the video here, and we're going to do this. So I'm going to stop the video here, and I'm going to pick up here on the next video because that way I can make the videos 6-8 minutes each.